Good morning, learners. Today we are going to present, I'm going to present differential calculus, but the focus will be on cubic function. So this topic is presented by Meli Shupi LM. So let me first start by welcoming all of you to today's visual. Right. Now, introduction. Remember, I did explain that the focus today will be on cubic function. Now, cubic functions are of the form y is equals to ax cubed plus bx squared plus cx plus d. And then the highest power of degree of a cubic function is 3. This also tells us that the graph will have at most 3 x-intercepts. Remember, I did mention that at most. So that will always not be the case always. Now, there are two general shapes of cubic functions depending on the value of the coefficient of x squared, x cubed. Now, when a is greater than 0, the graph starts out concave down, which is a set face, and it ends up concave up, happy. When a is less than 0, the graph starts out concave up, happy, and then it ends up concave down, sad. Right. Now remember, this is what I've been explaining on my previous slides, that if a is greater than 0, these are the possible shapes. So the first shape, when a is greater than 0, I did explain that it will start with a set face. So which means my cubic function, it will start by increasing and then decrease and then increase again. So whenever the value of a is positive, I know that I might have these 3 different shapes. So these are the 3 possible shapes that you might get. And then if a is less than 0, these are the possible shapes that you might get. Remember, I also explained that it will start with a happy face and then it will end with a sad face. So therefore, if a less than 0, our graph will decrease, start with decrease. It will start with decrease and then increase and then decrease. So whenever a is less than 0, we know that our graph must start with a decrease shape, a decrease. So it must first decrease and then increase and then decrease again. So now when you look at our possible shapes, let me go back to my previous slide. So whenever we have 2 stationary points, so your shape will definitely have increase, decrease, increase. But when we have 1 stationary point, when we have a one stationary point, our this will be the shape of our graph, which now has an increase and then a slight, more like a decrease and then again increase. And then if we do not have no stationary points, which simply means our graph only have a point of inflection, this will be the shape, an increasing shape. And then in a case whereby a is less than 0 and then we have 2 stationary points, our graph will start by decreasing, increasing and decreasing again. And then if we have 1 stationary point, our graph will decrease and a bit of increase, then decrease again. And then no stationary point, our shape will only decrease. So that is the most critical, important information that you need to know under cubic functions. So, yes. Now, remember, like any type of a function, you will need to sketch. So when sketching a cubic function, these are the points. These are some of the things that you need to have. So when sketching the graph of a cubic function, the following details have to be shown on the graph. Number one, we need x-intercepts. We need y-intercept, stationary points, the point of inflection. And remember, the graphs do not have to be drawn to scale, but the shape must be clear. It is advisable to start by calculating the what? The stationary point, since the number of stationary points also determines what? Determines, sorry, the shape of the what? Of the graph. So whenever you are told to sketch, these are what? These are the most important details that need to be shown on the graph. So let us now look at our examples. So now examples on sketching. Remember, we will look at the first one. You are now requested to sketch the graph of the following. So the first graph is what? The graph of f of x is equals to x cubed minus 5x plus 3. Remember, we said the graph is f of x is equals to x cubed minus what? Let me go to my previous slide. It's plus x squared minus 5x and plus 3. So remember, when we now look at our previous slides under graphs, remember we said what? It is advisable to start by calculating the what? The stationary point, so that you could see the shape of your cubic function. So now remember, let us now look at the function given. It is f of x is equals to x cubed plus x squared minus 5 plus x. So now remember calculating your stationary points, these are your stationary points. Now when we calculate your stationary point, we do what? We first find the derivative of your graph f prime of x, and then we equate the derivative of your cubic functions to our function to 0. So now we will take your function f of x and find the derivative, and then do what? Equate the derivative to 0. So that will be what? It will be f prime of x. It is equals to, remember, you deriving already. You would have done it in what? Rules. So now you multiply 3 by 1, which is the coefficient of x cubed. It will be 3x. And then subtract the exponent 3 by 1. And then it will be 2. So now it will be 3x squared plus, you multiply 2 by 1 is 2. And then 2 minus 1 will be 1, 2x. So remember, we do have the special cases like this one. The derivative of x, we know we normally take the what? The coefficient, which is -5 in our case. And now that you have derived your function, your cubic function, you will then have to what? Have to take the derivative equate to 0. Now you will say 3x squared plus 2x minus 5 equals to what? Equals to 0. Now that your derivative is equated to 0, remember to factorize, you can also use the quadratic formula, because this is the quadratic. So therefore, quadratic formula, it is x is equals to negative b plus or minus the square root of b squared minus 4ac, all over what? All over 2a. And then we substitute. It will be minus 2 plus or minus the square root of what? Of b, which is 2 squared minus 4 into 3 and then negative 5 all over 2 times 3. And then you take your calculator. Apologies, I wanted now to put my calculator on top so that we substitute together, but otherwise that will be rectified. So you must substitute negative 2 plus square root of 2 squared onto your calculator, multiplied by 3 multiplied by negative 5 all over what? All over 2 times 3. So now the value of your stationary, the x value of your x stationary point is x is equals to what? 1 or, and then the other value of your stationary point would be what? It will be x is equals to negative 5. Yes. Now that we are here, let us remember that, let me go back to my previous slide. What did I say? The minute, these are the 3 possible shapes. Now, the minute you have 2 stationary points, so that simply means the minute you have 2 stationary points, this will be your shape. Not forgetting the value of A, the contribution of A to the shape of the graph. So that means when you look at your cubic function, A, which is the coefficient of x cubed, is positive. And then we have 2, so this is negative 5 over 3, yes. And then we have what? We have 2 stationary points. So that simply means your shape, because A is positive, you have 2 stationary points. This will be the shape increase, decrease, increase. So this is the shape that we will be sketching. So before you attempt to do anything, step number 1, you first find your stationary points to first identify if your function has 2 stationary point or 1 stationary point or no stationary point, so that you could know the shape, the possible shape that you must sketch. And then now, after finding the x values of your stationary point, you must take each x value, you must substitute these values onto what? On your what? On your given function. So now you will say f at 1, it is equals to what? It's equals to 1 cubed plus 1 squared minus 5 times 1 plus 3. And then this is equals to, remember now, we need to calculate the corresponding y values. If I substitute 1 on my cubic function, I will have times 1 plus 3. So the value there is 3. It's 0. So me substituting 1, I will then have what? I will have 0. So f at 1 is equals to 1 cubed plus what? Plus 1 minus 5 times 1 plus the value I'm getting there is 0. And then I also substitute f at negative 5 over 3. Therefore, negative 5 over 3 cubed plus negative 5 over 3 squared minus 5 into negative 5 over 3 plus 3. This is equals to, and then substituting the other stationary point, I will definitely have, let me substitute, the value there will be 256 over 27. And then on your calculator, when you press SD, it will give you something like 9,48. But let us remember, what are stationary points? Stationary points are your turning points. Please do remember that. Stationary points are your turning points of your cubic functions. So these are your what? Are your turning points. So whatever I'm calculating now, I'm calculating your turning points of your cubic function. So therefore, after now calculating my stationary point, let us remember what is it that is required for me to sketch a cubic function. We require that to must what? Find the intercept with the axis. So let us calculate the x-intercept. So now calculating the x-intercept of your cubic function. Remember, for x-intercepts, you must let y 0. So now remember, f of x, it simply means is the notation. So therefore, where I see f of x, I will then substitute by 0. So 0 is equals to x cubed plus x squared minus 5x plus 3. And then now, remember, because it is a cubic function, and when I look at my cubic function, there is no way that I will factorize by grouping. No. If I try to factorize by grouping, I won't get the factors. So how do I then calculate the factors of my cubic function? I will do what? I'm going to take the last term, which is my constant, which is in this case is 3, and then get my constant is 3, and then I'm going to look for factors of 3. Factors of 3 are 3 and 1. And then now I look at the coefficient of x cubed. The coefficient of x cubed is what? Is 1. So factors of what? Factors of 1 is 1. So then both factors of 3 I divide by 1. So now more it will be plus or minus, plus or minus. So therefore 3 divided by 1, I will definitely get 3. So more I will have plus or minus 3. And then the other one, it will be plus or minus 1. Plus or minus 1, yes. Now what do I do then? I will take the values, positive value of 3, and substitute. Remember, for me to get my x-intercept, if I substitute 3 here, it must definitely give me 0. If not, it simply means 3 is not a factor. And then I will take also negative 3 and substitute negative 3 there. If it does not give me 0, I will know that no, negative 3 is not a factor. Now that I'm done with plus or minus 3, I will then use what? Plus or minus 1. So one may ask, Mary Shupi, where does plus or minus comes from? Remember, I did indicate to take factors of 3. Factors of 3 are what? Are 3 and what? And 1. So your numerator is factors of 3, and then your denominator is factors of what? Of 1, which is 1 and 1. So now it's plus or minus. So as finding the factor, we know that a factor, when I substitute a value more where I see x in place of x, it must give me what? It must give you 0. That is how we normally find the factors. Yes, I'm quite aware that when we substituted 1, I believe when we were calculating the stationary value, stationary points, when you substitute 1, the answer we got was 0. Of which I believe in this case, in this scenario, it was a blessing. But I was also making you aware that this is the correct way of finding what? Of finding your factors. Yes. So now, because we now know in this case, in this specific case, we know that 1 is our factor. So we will use 1. Ne? Or we might use any of the values and see if we could get 0. Right. So now we can use positive 3. So 3 cubed plus 3 squared, 3 to the power of 3 cubed plus 3 squared minus 5 times 3 plus 3. So when I substitute positive 3, I do not get 0. I get 24. And then when I substitute negative 3, I get negative 30. Let me check negative 3. Wait a minute. When I substitute negative 3, I get 0. So in this case, I will use negative 3 instead of 1, just to show you that it works for any factor that you might get. So I will use negative 1 as one of my factors. So now I know that negative 3 is a factor, because when I substitute f at negative 3, my answer is what? My answer is 0. I get 0. So then I know that f at minus 3, it is what? It is 0. So now I know that f at minus 3 is a factor. Therefore, I'm going to use minus 3 to do what? To factorize my to factorize my cubic function. So now I know if it's a factor, when I take it back onto on my bracket, it will be x plus 3. And then now this is equals to 0. I'm left with this bracket. So normally what we do when we factorize a cubic function, we normally use the synthetic method, negative 3, and then yes. And then we will have negative 3. And then more, you use your what? Coefficients of x cubed. In this case, coefficient of x cubed is 1. Coefficient of x squared is 1. Coefficient of x is negative 5. And then your constant is 3. So now that we are here, normally what we do, the first coefficient of x cubed, we will add it by 0. And then 0 plus 1, we know we will get 1. Or normally we can say we bring it down. Bring it down. So then you multiply negative 3 times 1. It will give you negative 3. Remember, you are adding 1 plus negative 3. 1 plus negative 3 will give you negative 2. And then negative 3 times negative 2, it will give you 6. And then you add negative 5 plus 6. It will give you 1. And then minus 3 times minus 3 multiplied by 1. It is negative 3. And then 3 plus negative 3, the answer is 0. And then remember, yes, this is the quickest and the easiest way to factorize a cubic function. So therefore, we will take minus 3 back to factor. It will be x plus 3 bracket. Now, 1 minus 2 minus 1. Now, these represent what? They represent coefficients of your quadratic. Remember, quadratic, this will be A, B, and C. So your quadratic is ax squared plus bx plus c. Now where you see a, we will substitute by what? By 1. So it will be x squared. And then b will be what? Minus 2x. And then your constant term will be plus 1. Remember, we are solving for what? We are solving for your x-intercept. So remember to equate to what? To 0. So now that you equate to 0, now this is your quadratic. So you are more than welcome to use your quadratic formula to factorize your quadratic expression. So therefore, we will have x plus 3. And then more, you can use your quadratic formula to factorize that one. So it will be x plus x minus, and then x minus 1 minus 1. So therefore, your x-intercept will be x is equals to negative 3 or x is equals to 1. So if you check your x-intercept, we have x minus 1, x minus 1. So now that we do have x minus 1, x minus 1, it simply means your cubic function. What it does, it now turns on your what? On your x-intercepts. So then, remember, we are still on the sketching part. So for more, what we do then, you find your y-intercept. So your y-intercept, you know, you let x 0. So for your y-intercept, you must let x 0. So that will be f at 0 is equals to 0 cubed plus 0 squared minus 5 times 0, and then plus 3. So therefore, f at 0 is equals to what? 3. That means your y-intercept, your coordinates of your y-intercept will definitely be 0 is to 3. And then your coordinates of your x-intercept will definitely be what? Minus 3 is to 0. And what? 1 is to 0. So if you check, even your cubic function, it has the same x-intercept and the same stationary point. All right. And then remember, let us go back and recall what do we need for us to sketch. Remember, I did emphasize that these details have to be shown. Your x-intercept, your y-intercept, your stationary point, which is your what? Your turning point. And then the point of inflection, of course. So now when it comes to your point of inflection, it is a point now where your cubic function changes your concavity from concave down maybe to concave up, or vice versa. Now to determine your what is this? To determine your point of inflection, you definitely need the what? To derive the second derivative. So your second derivative, remember, this is your first derivative, f prime. It represents first derivative. And then for your stationary, your point of inflection, you will take your first derivative and derive it again, so that you now do what? You now get your point of inflection. So therefore, already I know that f prime of x is equals to what? Is equals to 3x squared minus plus 2x minus 5. And then for me to calculate the what? The point of inflection. This is a point of inflection. So therefore, second derivative is equals to what? You multiply 2 by 3, it will be 6, and then subtract the exponent by 1, it will be 6x. Remember, it's a special case whenever we have x, derive x. Remember, if the exponent of x is 1, when we derive, we normally take the coefficient. In this case, the coefficient is 2. So it will be plus 2. And then because we are calculating the point of inflection, you will take your second derivative and equate your second derivative to 0. So therefore, yes, let me first erase this part. So that I create more space. So we were now calculating the point of inflection of your cubic function. So therefore, point of inflection of your cubic function, it will be what? Second derivative is equals to 6x plus 2. And then 0 is equals to 6x plus 2. And then you use the additive inverse. Normally in mathematics, it's additive, even though we say you transpose. Therefore, minus 2 is equals to 6x divided by 6 divided by 6. Therefore, the x value of your point of inflection will be x is equals to negative 1 over 3. And then the value of x, you take the value of x and substitute it into the what? Into the original cubic function. So f at negative 1 over 3 is equals to what? Negative 1 over 3 cubed plus negative 1 over 3 squared minus 5 into negative 1 over 3 plus 3. And then you use your calculator to punch. So to substitute negative 1 over cubed plus negative 1 over 3 squared, and then all squared, minus 5 into negative 1 over 3 plus 3. And then the answer would be 128 over 27. So now before I erase, remember now we are coming to the sketch part. So now I need to do what? I will write down the coordinates of my TP, which is my stationary points. The first stationary point is 1 is to 0. And the second stationary point is what? Is negative 5 over 3 is to 256 over 27. So these are my two stationary points. And then what you then do, you will then sketch. So remember, I also highlighted that even if the diagram is not drawn to scale, you can definitely do what? You can sketch. So your diagram, it does not need to be on scale. Reason being, I did say you don't have to be drawn to scale, but the shape, it must be clear. The shape must be clear and the intercepts indicated must be clear. So that is what is important. And then now what do we then do? You are then supposed to sketch. So then when we sketch your cubic function, this will be my y-axis and then this will be my x-axis. Right. Okay. You sketch your cubic function and then this will be my y-axis, yes, and then this will be my x-axis. So remember, you first start by indicating all the points on the Cartesian plane. Let us start with the intercept with the axis. So for your x-intercept, remember we said we have -3 is to 0 and 1 is to 0. So now this will be my x-intercept, -3, and then this will be my x-intercept 1. And then now we also indicate your y-intercept, 0 is to 3. This will be my y-intercept 3. So these are the what? Are your intercepts with the axis. And after indicating your intercept with the axis, you then have to indicate your turning points. So now I could see that this turning point is here. And then -5 over 3. Remember, you will have to press SD on your calculator to find plus or minus -5 over 3 is what? So -5 over 3 is what? Is -1,67777. Right. And then 256 over 2 is what? 256 over 26, I believe, yes. It's something like, I believe Mona is 26, yes. It's something like 9,887, yes, something like that. So now when we sketch that, we know that -1,67, it lies between -2 and -3, -2 and -1. So this will be your -1, mamang. And then somewhere they will have 9. And 9,87. Yes. So let us remember the shape. So the shape. Now we can now do what? We can now look at the shape. So the shape is increase, decrease, increase. And then now what you then do, remember your shape, it must touch all these values. So then it will be increase, increase, decrease, and increase. So this will be your shape. So now, and then more we know the turning points are what? -5 over 3 is to 256 over 26. And then as for point of inflection, the point of inflection is somewhere here, -1, and then 128 over 27 would be 4, something. So the point of inflection will be somewhere here. So that will be your point of inflection. Remember, the diagram is not drawn to scale, hence you would see such discrepancy because 9 comma something, it cannot be here, it's way above 3. But nonetheless, the shape is correct, the intercept with the x is correct. I also have what? I also have my y-intercept and my, most importantly, my turning points. So this is how you should do what? This is how you should sketch your cubic function. So let us also look at another example on sketching, because remember, when you are required to sketch, I did mention that we do have what? About 3 possible shapes. So we might have a shape where x is less than 0, a shape where x is greater than 0. So these are the 3 possible shapes, and then we need you to master the sketching part. And then now the second one that we'll be sketching is f of x is equals to what? Is equals to negative 3x cubed minus 3x squared plus 9x plus 27. So this is the second shape that you will be what? That you will be sketching. Now on the second cubic function that you will be sketching is f of x is equals to negative x cubed minus 3x squared then plus 9x plus 27 plus 9x plus 27. So step number 1, remember, for you to determine the exact shape, you must first find your what? You must first find your stationary points so that you could identify whether your function, does it have 2 stationary points or does it has only 1 stationary point or no stationary point. So, and then the shape is, and the value of a, you also identify the value of a. The value of a is what? The value of a is negative. So we know that if a is negative, your shape will start with what? Decreasing. So then that is where you start. You start by first calculating the stationary points, which is your what? Your turning points. So calculating stationary point, it requires you to first find the first derivative. So now finding the f prime of x, which is my first derivative, it is equals to what? Negative 3x squared minus 6x plus 9. After finding my first derivative, I will then have to take my first derivative equate to 0. So negative 3x squared minus 6x plus 9 is equals to 0, remember. So after now equating my first derivative to 0, what is it that I must do? Because I could see that now my equation is a quadratic equation. I can use my quadratic formula to calculate the x values of my turning point. So therefore, I know my quadratic formula is remember also your quadratic formula, it is provided to you on your information sheet. So please don't shy away from using your information sheet. Make sure that you do use your information sheet to take out that quadratic formula. So x is equals to negative b plus or minus the square root of b squared minus 4ac. So all over 2a. So my advice, use quadratic formula because you won't get the x values wrong, incorrectly so. So now you substitute, it will be x is equals to negative bracket. Whenever you substitute, remember that you must include the bracket. So it will be negative. This negative is from the formula. So negative bracket, open bracket, negative 6, close bracket, plus minus the square root of what? Negative 6 squared minus 4a, which is negative 3, and then c, which is 9, all over 2 times a, which is negative 3. And then you press on your calculator -6 plus the square root of -6 squared minus 4a, which is -3, and then c, which is 9, all over 2a, which is -3, all over 2a, which is, yes, the answer there, x is equals to -3, or, and then the value of x would be what? The value of x will definitely be equal to 1. Now, after finding my x values of my what? Of my TP, remember, it's your turning point of your cubic function, although we are saying the stationary point. So now, after calculating my x values of my stationary points, I did explain that to take these values, substitute them back into the original formula. So therefore, f at -3 is equals to what? Negative bracket minus 3 cubed minus 3x squared. Apologies. I must substitute the value of x. So therefore, it will be minus bracket -3 squared plus 9 into -3 plus 27. So when I substitute -3 on my cubic function, I -3 bracket minus 3 squared plus 9 into -3 plus 27, and then the answer is 0 again. All right. So therefore, and then f at 1 is equals to, so substituting 1, it will be what? When I substitute the value of 1, I get 32. So it will be -1 cubed minus 3 into 1 squared plus 9 into 1 plus 27. And then the answer is 32. So when you check the 2, the first example of which I did, when we substituted 1, we got 0. So now again, when we substitute -3, we get 0 again. Now this tells us that if we substitute -3, 0, this value is what? It is our x-intercept. It is our factor, because when we substitute -3, we get 0. So we'll definitely use -3 without wasting any time. So the coordinates of my turning points, which is my stationary point, are -3 to 0 and what? And the 1 is to 32. So these are my stationary point. And then for my intercepts with the x's, for x-intercepts, I know that I will have to what? I will have to let y 0. So 0 is equals to x cubed minus 3x squared plus 9x plus 27. So now I know one of my factors is negative what? Is -3. Without wasting any time, I will use my synthetic -3, remember. And then when you use synthetic, because when I first started, I did explain that our standard form for cubic function is ax cubed plus bx squared plus cx plus d. All the coefficients here must be there. Even if your cubic function only has 3 terms, whenever you could see, I don't see maybe x squared, in place where x squared was supposed to be, you must do what? You must make sure that you then substitute there by 0. So now in my case, the coefficient of x cubed is 1. Sorry, it's negative. Apologies. It's negative. Remember, we have -3x cubed is equals to -3x squared plus 9x plus 27. And then what you could do, you will then -1, -3, and then 9, and then 27. So remember, I did say you must add by 0. It will be -1. And then when you multiply, it will be +3. And then when you add, it will be 0. Right? And then when you multiply -3 by 0, it will be 0. And when you add, so for these two you are adding, let us remember you're supposed to add. And then when you multiply, -3 times 0 is 3. And then 9 plus 0, it will be 9. -3 times 9 is -27. And then 27 minus 0 is 0. So therefore, -3 as my factor, it will be x plus 3. Remember, I did indicate this is A, this is B, this is C of my quadratic. So therefore, A is -x squared, and then B will be 0. You can even substitute it 0x and then plus 9. This is equals to what? This is equals to 0. So therefore, we have x plus 3 bracket -x squared plus 9 is equals to what? Is equals to 0. So now what you can also do, you can factorize, take out a common factor, because we have what? Because we have -x squared plus 9. So therefore x plus 3 and bracket -x squared minus 9. All right, let me use different bracket so that I now, yes, I will definitely use this bracket to indicate that I'm now factorizing this term. So I took out -1 as a common factor. So -1 bracket x squared minus 9, and then this is equals to 0. And then negative bracket x plus 3. And then x squared minus 9 is difference of two squares. It will be x plus 3 and then x minus 3. This is equals to 0. Yes. Therefore, I will have x is equals to -3 or x is equals to 3. And then the coordinates of my x-intercepts will be -3 is to 0 and what? 3 is to 0. Yes. And then after calculating my coordinates of my x-intercepts, I will then have to calculate the coordinates of my y-intercept. So for y-intercept, remember I let x 0. So f at 0 is equals to -0 cubed minus 3 times 0 plus 9 times 0 plus 27. So therefore, the coordinates of my y-intercept, it will definitely be 0 is to 27. And then calculating my point of inflection, point of inflection, it will be what? I will have to, remember, you take your first derivative, and then you derive again, and then you equate to 0. So f derivative f prime of x is equals to -3x squared minus 6x plus 9. And then you then derived second time. Second derivative is equals to, remember, Mona squared, apologies. It will be -6x minus 6. And then you take your second derivative, equate to 0. My first derivative is -6x minus 7. So therefore, minus 6x minus 6 is equals to 0. Minus 6x is equals to 6. Divide by -6 both sides. Therefore, x is equals to what? Is equals to -1. So you take -1, you substitute -1 into f of x, you will get negative bracket -1 cubed, -1 cubed minus 3 into -1 squared, plus 9 into -1 plus 27. -1 cubed minus 3 into -1 squared plus 9 into -1 plus 2. And then the answer is what? Is -9. So the coordinates of your point of inflection is what? Is -1 is to -9. Now that you are sorted, you have your turning points, your x-intercept and y-intercept, and your point of inflection. Remember, I also indicated that the minute your cubic function has 2 stationary points, you must always refer back and remember that for a cubic function where a is less than 0, and then it has 2 stationary point, this will be the shape. So this is a possible shape. This is the shape. So our shape will be what? Our shape will definitely be decrease, increase, and increase again. So it will be decrease, increase, and decrease. Yes. So that is the shape that you are supposed to sketch. Let me erase here. To sketch the cubic function. Yes. Now that you will have your y-axis, x-axis, and therefore remember, you first start by plotting your intercepts with the axis. So now we have -3 to 0, and then this is -3, and then we have 3 to 0, this is 3. And then your y-intercept is 27. And then this is your 27. This is your y-intercept. And then, yes, after indicating your intercept with the axis, you will then look at your turning points. Your first turning point is -3 is to 0. And then the other one will be 1 is to 32. So 32 will be just above 27. And then what you then do, you will join the points looking at your shape. So remember your shape, it will have to start with decrease, right? And then it increases, and then it decreases again. So this will be your shape. And then, therefore, the y-intercept, we know it's 27. Your turning points are 1 is to 32. So this is how you label your what? Your cubic function. And then the point of inflection is what? -1 is to minus 9. I don't know if I pressed the calculator well. Let me check. I think I made a mistake. It can't be -1 is to -1. So it's negative into -1 cubed minus 3 into -1 squared plus 9 into -1 and then plus 27. Yes, I did mention maybe I made a mistake while pressing the calculator. So the x value of your turning point will be what? It is 16. Apologies. Your y value is 16. And then your point of inflection to be -1 is to 16, somewhere here. This is where you will find your point of inflection. So you must be very, very careful, especially now that you are supposed to use a calculator. Just make sure that your calculator, whatever you punch on your calculator, is 100% correct, because we don't want you now making mistakes in your what? In your exam. So I believe in my case, this is what you need to know when you sketch your cubic function. And then, yes, without wasting any time, I also have the last one, which I would like to do what? Which I would like to sketch on cubic function. So now the last one, which I also need to sketch under cubic function, is what? Is g of x is equals to x cubed plus 3x squared plus 6x plus 8. Now you are requested for you to do what? To plot the following cubic function. So remember, I did indicate my cubic function a cubed is greater. The coefficient of a is positive. So that simply means a is greater than 0. So whenever a is greater than 0, with me I have 3 different shapes, of which I know one of them is possible. So for me to determine whether it's shape A, shape B, or what, I must first find my stationary points. Because the stationary points, they will definitely indicate to me whether my cubic function, should it be what? Is either having 2 stationary points or 1 or no stationary point. So now let me first start by finding my stationary point. So now finding your stationary point, remember you derive f prime of x. Whenever you hear the word stationary point, just know you need to derive f prime of x is equals to what? 3x squared. Remember, I believe by now your educator at schools, they also did the rules so that you know where does 3x squared come from. Remember, you will multiply the exponent of x cubed by the coefficient of x cubed, which is what? Which is 1, and then subtract 1. And then plus 6x, and then plus what? Plus 6. So therefore, 0 is equals to 3x squared plus 6x plus 6. And then quadratic formula, x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. So therefore, when we substitute, we will have negative 6, remember, bracket on, plus or minus the square root of 6 squared minus 4ac. This is all over what? This is all over 2 times 3. Right. Now, when you substitute this quadratic equation into your quadratic formula, it will give you what? Math error. Reason being is that when you look inside your set, your square root, 6 squared is what? 6 squared is 36. And then when you multiply 4 by 3 is 12, multiplied by 6 is 72. So 36 minus 32, you will definitely have what? Negative 36. So that means for this one, there will be no what? There will be no solution for this one. Even if when you use your calculator, it will indicate to you that math error, which also now do what? Which also indicate no solution. So now that I know my cubic function, it does not have a stationary point. So I remember for a cubic function without stationary point, this is what is my shape. What will my shape look like? So this is a cubic function without any stationary point. So because the stationary point, there were no stationary points. And then likewise, you still have to calculate your x-intercepts. You still have to calculate your y-intercept. So let us calculate your x-intercept. Remember, for x-intercept, you let y 0. So we calculate your x-intercept. Calculating your x-intercept will be 0 is equals to what? X cubed plus 3x, 38. X cubed plus 3x plus 3x plus 6x plus 8. So now, as now determining your x-intercept, remember the method now. Now that you don't have any value there on my left, what to do? You will look at 8 and you must write all factors of 8. So factors of 8 are 1, 2, 4, and 8. These are the 4 factors of 8. And then each factor of 8, I will have to divide each factor of 8 with factors of 1. So factors of 1 is 1 only. So it will be 1, 1, 1, 1, 1. In a case whereby we had more than one factor of 1, we will change it to be 1 over 1, 1 over 2. 2 over 1, 2 over 2. 4 over 1, 4 over 2. In a case whereby we had more than a number which is not 1, a number which has more than one factor. That is how you were supposed to do it. In a case whereby we had 2 more, then you will substitute the denominator factors of 2. We will have 1 over 2, 1 over 1, 2 over 2, 2 over 1, 4 over 2, 4 over 1, and so forth. But in this case, we only have 1 as a factor. So for each, you must now do what? It must be plus or minus the value. So the value is either positive or negative. And then what to do, you will take, remember 1 over 1 is 1, of course. So more, you will write the answers. So it means more it will be plus or minus 1. More you substitute plus or minus 2. You substitute plus or minus 4. You substitute plus or minus 8. So whichever value, whether being it positive or negative, whichever value that will give you 0, then you know that value, it is your factor. So let us start by substituting 1, of course, positive 1. You will substitute 1 cubed, it will be 1 cubed plus 3, remember more it's squared, apologies. It will be 3 squared, 3 into 1 squared, plus 6 into 1 square 1, plus 8. So when I substitute 1, I get 18, so which means 1 is not a factor. And then when I substitute negative 1, when I substitute negative 1, substituting negative 1, I get 4. And then now I know positive 1 and 1, no factor. I move on to the next factor, which is positive 2. I substitute 2. When I substitute 2, I get 40. So that means positive 2 is not a factor. When I substitute negative 2, yes, I get 0. So that simply means when I substitute f at minus 2, that is when now I got 0. So therefore, yes, so what I did, I took all the values and start substituting. Hence, when I started, I apologize. I really wished we had a calculator on the screen so that you could see us now going through it, doing trial and error. So you can also find these factors using what? Trial and error. So when I substitute minus 2, that is when I got 0. So that simply means x being negative 2, it is a what? It is a factor. So therefore, now I will definitely use my synthetic to calculate for my x-intercepts. So remember the standard form of your cubic. You must substitute the coefficient of x squared, x cubed, substitute the coefficient of x squared, and then substitute the coefficient of x, and then more you must substitute, the constant term. So the coefficient of x cubed is 1, coefficient of x squared is 3, coefficient of x is 6, and then the constant term is 8. I also did mention in a case whereby your cubic function only has 3 terms, the first more we must always include what? All 4 of them, even if on your cubic functions you only have 3 terms. So now I did mention that you add the first one by 0. So you add 1 plus 0, which is 1. It's you add, and then you multiply. You will multiply minus 2 by 1. It will give you negative 2. And then 3 plus negative 2 is 1. and then you multiply what? Minus 2 by 1, it will give you negative negative 2, and then you add 6 plus negative 2, it will be 4, and then you multiply what? Negative 4 by what? By 4, I'm sorry, negative 2 by 4, it is negative 8, and then when you add 8 plus negative 8, it's 0. So therefore, as a factor, we will have x plus 2, and then x squared plus x plus 4. Because remember, we are solving for the x-intercept. Remember to equate that to what? To 0. So now that we are here, we now notice something. Also, my what? My x-intercept will be 1, because when I try to factorize this, you can also use quadratic. So remember, this is a quadratic expression. You can also use quadratic, negative 4 plus or minus the square root of b squared minus 4ac all over 2a, and therefore x is equals to negative 1 plus or minus the square root of 1 squared minus 4a, which is 1, and then b, which is 4, all over 2a. So you will then find out that for this expression, quadratic expression, there will be no solution, and then the other x value will be what? Your x-intercept will be what? X is equals to negative 2. And then for your y-intercept, remember, for your y-intercept, we will let y x 0. Hence, we normally say g of 0 is equals to 0 cubed plus 3 times 0 squared plus 6 times 0 plus 8, and then the answer will be 8, and then the coordinates of your y-intercept are 0 is to 8. And then you have to calculate your point of inflection. Point of inflection, remember, it comes from what? From your second derivative. You must then use your first derivative to determine your point of inflection. Therefore, f prime of x was what? Is equals to 3x squared plus 6x plus 6. Therefore, second derivative is equals to 6x plus 6. Therefore, 0 is equals to 6x plus 6. Negative 6 is equals to 6x. Divide by 6, divide by 6. Therefore, x is equals to what? Negative 1. And then you substitute f at negative 1 to calculate the point of inflection. Negative 1 will be negative 1 cubed plus 3 into negative 1 squared plus 6 into negative 1 plus 8. So f at negative 1 is equals to 3 bracket negative 1 squared plus 6 into negative 1 plus 8, and then the answer will be 4. So the coordinates of your point of inflection, negative 1 is to 4. Right. So remember, we are now sketching a cubic function without what? Without your stationary point. So just to remind you guys, a cubic function without a stationary point, where the value of a is possible, this must be the shape. So this is the shape of the cubic functions, a cubic function that I will be plotting. So therefore, let me erase. Now we are plotting. Remember, I did indicate that when you plot the cubic function, you start with the what? With the intercept, with the axis, and then you will join them later. So now this is your y-axis, x-axis. So you then plot. Remember, the coordinates here are minus 2 is to 0. So minus 2 is to 0 is here. And then your y-intercept is 8 is to 0, somewhere here. And then your point of inflection. Your point of inflection is -1 is to what? -1 is to 4. So -1 is to 4 is somewhere here. So this is -1, this is 4, right? So then you sketch. When you sketch your cubic function, remember the shape is supposed to be like this. And then you. So let us remember the shape is like that. So therefore, this will be the shape of the cubic function. Where now more we have point of inflection, -1 is to 4. So this is also your cubic function where now we do not have any stationary point. Now because of time, I won't sketch. The only cubic function that I won't sketch is the one with one stationary point, because we still have more slides. I still have to do more of cubic functions. So because of time, I won't be able to sketch the cubic function, which has now one stationary point. But so far so good. Under sketching, we sketched a cubic function where a is negative. We also sketched a cubic function where a is positive, which is now a positive, and also a cubic function where a is positive, but it has no stationary points. So these are the most important things that you must remember whenever you sketch a cubic function. So now when you sketch a cubic function, let us always remember the possible shapes. And for you to be able to sketch a cubic function, you first need to find the stationary points. Your stationary points are your turning points. So whenever you have two stationary points, you know this is how your cubic function should be like. When you have one stationary point, this is how your cubic function should be like. And then when you have no stationary point, that is the shape of your cubic function. And to sketch your cubic function, you will need your x-intercept, your y-intercept, and also you can also find the point of inflection, including your stationary point. Now, we now move on to our next skill under cubic functions, which is finding the equation of a cubic function. Now, remember, like any functions, you are required to sketch. Now also you are required to interpret, which is now you having been given a sketched function. So now when we find the equation of a cubic function, the x-intercepts of a cubic functions are x1, x2, x3. Then the equation of a cubic function is given. So whenever you are given 3 x-intercepts, then you know finding the equation of your cubic function, you will have to use the equation y is equals to a bracket x minus x1 close bracket x minus x2 x minus x3, where x1, x2, x3, they are what? They are your x-intercepts of your cubic function. And then if one of the x-intercept is also a turning point, remember the previously I sketched such. So now if one of your x-intercept is your turning point, now that can be expressed what? Again, we know we will have x minus x1, and then x minus x2, where now you will be having the same bracket, because now one of your x-intercept is your what? Is your turning point. So that x-intercept, where now is your turning point, it simply means you will have to repeat the what? The x-intercept. And then where now x1 it represents what? That x-intercept that is used twice, and then x minus 2 will be the other x-intercept. And then now also, if a cubic function has a stationary point of inflection, if a cubic function has a stationary point of inflection, so now because our cubic function, it has a stationary point of inflection, what we then do, the equation, then the function is given by what? Is given by y is equals to a into x plus p cubed plus q, where p and q are what? These are your point of inflection or your stationary points. Right, now let us look at the examples. So now you have to determine the equation of the following cubic function. So now let us look at the first one, A1. Remember, we are now given 3 x-intercepts. So whenever you are given 3 x-intercepts, we still remember that if we are given 3 x-intercepts, I will just draw a rough sketch so that we now have, yes, -1, 1, and 3, increase, decrease. All right. So this is your cubic function. It is -1, 1, and 3. So you are supposed to determine the equation of the function. So now for us to determine the equation of the function, our cubic function, it has 3 x-intercepts. So I did mention earlier, finding the equation where now we have 3 x-intercept. This is what we use. We will use the equation y is equals to a bracket x minus x1, x minus x2, and x minus x3, where now x1, x2, x3 represent your x-intercepts. So y is equals to a bracket x minus, the first x value is -1, it will be x minus -1, and then the second x-intercept will be x minus 1, and then the third x-intercept will be x minus 3. So therefore, y is equals to a bracket, it will be x plus 1, and then x minus 1, x minus 3. That is where we start. And then you were given a point on your cubic function, which is 2 is to -6. So the point given on your cubic function is 2 is to -6. And then now we need to calculate the value of a. For us to calculate the value of a, we must substitute. We must substitute the point 2 is to -6. That means where we see x, we substitute by 2. And where we see y, we substitute by -6. So therefore, -6 is equals to what? A, because we need to find the value of a, bracket 2 plus 1, and then 2 minus 1, and then -6 minus 3. We substituted where we see x by 2. Sorry, it must be 2. It must be 2. Where we see x, we substitute by 2. And then where we see y, we substitute by -6. And then therefore, -6 is equals to a. Remember, 2 plus 1 is 3. So we will have 3 multiplied, and then 2 minus 1 is 1. And then multiplied by 2 minus -3 is -1. And then the answer more, it will be 2. It will be -3. 2 plus 1 is 3. And then more we have -1. And then -1. So 3 times 1 times -1, it will give you -3. And then now we have to calculate the value of a. We will divide both sides by -3. Therefore, a is equals to what? Is equals to 3. So now remember, you were told that you must find the equation, and then you must now do what? Ensure that your equation is in this form, ax cubed plus bx squared plus cx plus d. So therefore, y is equals to what? Is equals to 3 bracket x plus 1, x minus 1, x minus 3. And then now we have to find the product of these three brackets. So I will suggest that you first find the product of these two brackets, because I believe it's easier with working with these two first. So when you then find the product of these two, after finding the product of the two brackets, we'll have to find the product after of the other third one. So y is equals to 3 bracket. Remember, x plus 1, x minus 1 is difference of two squares. But we can also make sure that you multiply it using FOIL method so that you avoid making any mistake. So x times x is x squared. X multiplied by -1 is minus x. And then 1 multiplied by x is plus x. And then 1 multiplied by -1 is minus 1. And then x minus 3. So -1 plus 1 is 0. Although we normally use we cancel, please let us try to rectify that. We are adding the coefficients. So when you add -1 plus 1, you will definitely get 0. So therefore, y is equals to 3 bracket x squared minus 1 and then x minus 3. And then the same procedure again, you use your FOIL method to what? To use the distributive property of the FOIL method to find the product. So x cubed, you multiply x squared by x, you multiply x squared by minus 3, it will be minus 3x squared minus 3 minus 1 times x, it will be minus x. You multiplied -1 by 3 minus 3, it will be plus 3. And then when you look at my expression is x cubed minus 3x squared minus x plus 3. So there are no what? There are no like terms. So now I will have to multiply the bracket by 3 throughout. So each term, I will have to multiply each term by 3. So therefore, y is equals to 3x cubed and then minus 9x squared minus 3x plus 9. So that is the equation of our cubic function, where now you are given 3x intercepts. And then the second one, you are given this one, where now you are given 2 what? You are given 2 x-intercept, we have minus 2 and 3. But at 3, remember, what did we explain is that at the minute we have a turning point on your x-intercept, this x-intercept can be used twice. So the minute we have a turning point at your x-intercept, that x-intercept can be used twice. So you follow the instructions. So it will be minus 2, 3, okay? So your cubic function, just a rough sketch. I'm trying my level best to draw, but yes. So it is what? It is minus 2 and 3 and 18. I believe it's something like this. Let me double check. Yes. So therefore, we have minus 2, we have 3, and then we have minus 18. So that is plus or minus the sketch, your sketched cubic function, yes. So now you have to also determine the equation of this cubic function in the form. All right. So now we have identified, we have two x values, x-intercepts I meant to say, but now at 3, we have a turning point. So I did indicate that the minute we have a turning point, that turning point, it may be represented twice. So therefore, y is equals to what? A bracket x minus x1, and then x minus x2, x minus x2. Where now x2, my x2, it represents that x value, that x-intercept where we have a turning point. So y is equals to a bracket x minus minus 2, which is our first x-intercept, -2, and then bracket x minus 3, x minus 3. I believe by now you must have noticed whenever I substitute a negative value, I substitute including bracket, so that you could see that we will multiply -1 by negative, negative by negative, and then we will get positive. So whenever I substitute an x-intercept that is negative, I normally include the bracket. All right. So then we will have y is equals to a bracket x plus 2, and then x minus 3. You can even square it because this is the same bracket. So whichever way works for you, you can either even decide to square that -3. And then we now need to determine the value of a. So for us to determine the value of a, we will have to substitute a point. So the point that we have on our graph is your y-intercept. So your y-intercept, this is your y-intercept. The coordinates are 0 is to -18. That simply means where we see x, we substitute by 0, and then where we see y, we substitute by -18. So therefore, -18 is equals to a bracket 0 plus 2, and then 0 minus 3 squared. So minus 18 is equals to, and then, yes, 0 plus 2 is 2, multiply by 0 minus 3 is -3, and then when you square -3, you will get what? 9. So 2 times 9 is 18, so we will have 18a. And then you divide both sides by 18. Therefore, a is equals to -1. And then you substitute the value of a. Y is equals to negative bracket x plus 2, x minus 3, x minus 3. So now I've decided to expand the brackets, because now the equation must be where we must put the equation in the form of ax cubed plus bx plus x squared plus cx plus d. So this is y is equals to negative x plus 2, and then you first find the product of these two brackets, whichever bracket you may start with. You can start with x plus 2 multiplied x minus 1, or you can use x minus 3, x minus 3. But let us remember FOIL. So x times x is x squared, and then minus 3x, and then minus 3x, and then plus 9. So therefore, y is equals to negative x plus 2. You add the like terms. So x squared minus 6x plus 9. And then after, you must also find the what? You must now find the product between our binomial and trinomial. You will multiply x by x squared. It will be x cubed. You multiply x by -6x. It will be minus 6x squared. You multiply x by 9. It will be plus 9x. Then you multiply 2 by x squared. It will be plus 2x squared. You multiply 2 by -6x. it will be minus 12x. You multiplied by positive 2 by 9, it will be plus 18. And then after multiplying, finding the product of these two, binomial and trinomial, you first start by doing what? You first start by what? You first start by adding the like terms. So our like terms is what? Is we do have minus 6x squared and plus 2x squared. And then we also have 9x and minus 12x. So we add the like terms. So therefore, y is equals to negative bracket x cubed, and then minus 6 plus 2, it will be negative 4x squared, and then 9 minus 12, so 9 minus 12 is negative 3x plus 18. So therefore, after adding the like terms, you will have to remove the bracket by multiplying throughout the expression by a negative 1. So the answer will be negative 1 times x cubed is negative x cubed plus 4x squared plus 3x minus 18. That will be our equation of our cubic function. Right. And then, all right, let me not do 3 and 4. It's a repetition. Yes. And again, we are still determining the equation of the cubic function. So when I look at this type of a cubic function, now this type of a cubic function is a cubic function that has a stationary point of inflection at what? At that specific point. So this is the same as that. So I did mention whenever we have a cubic function that has a stationary point of inflection, remember, normally we will say the equation should be y is equals to what? A bracket x plus p squared plus q. So we look at P and Q are your what? Your point of inflection, your what? Your stationary points. So when we then find the equation of this type of a cubic function, first step number 1, let us substitute. So now the coordinates will be y is equals to a. It's cubed here, not squared. Apologies. So it will be what? X. Remember, the y value of your stationary it's 0. So it will be x plus 2 cubed, because we do have negative. So if it's negative, it must be plus 2 cubed. And this will be what? Plus 0, because the value of your what? The value of y is what? Is 0. So whenever we deal with such, let us remember the equation of the function is given as what? So the equation of our function is given as x plus p cubed plus q, where what? At what? Point of inflection at what? Negative p to q. So we use the coordinates here to substitute there. Hence, now in my case, y is 0. I apologize. This is x. So the coordinates here are supposed to be 0 is to negative 2. Yes. The coordinates are supposed to be 0 is to negative 2. So therefore, this is plus q. So y is equals to a bracket. It will be x. The x value there of the point of inflection is what? Is 0 cubed, and then y is what? Minus 2. So therefore, we will have y is equals to what? Y is equals to ax cubed minus 2. Yes. So x plus 0 is 0. and then cubed, it will be x cubed. And then you substitute a point. So in this case, our point is 1. So we will definitely substitute the point is your x-intercept. 0 is to 1. 1 is to 0, yes. And then from here, where you see x, you substitute 1. And then where you see y, 0. So therefore, 0 is equals to a bracket 1 cubed minus 2, and then 2 is equals to a. Remember, 1 to the power of 3 is 1, and then negative 2, we normally use additive. So additive inverse, you add by 2 both sides. That is the correct mathematics. Other than that, we normally say you transpose minus 2, that will be what? Positive 2. So therefore, the value of a is what? The value of a is 2. Therefore, the equation of your cubic function will be 2x cubed minus 2. Yes. And then we move to B2. So same procedure with regard to B2. You will still apply the same procedure. So on B2, you will have y is equals to a x plus p cubed plus q. So let us remember P and Q, they represent the point of inflection. So in this cubic function, our point of inflection is here. And then the coordinates are 1 is to 0. So please avoid making such mistakes. Make sure that you write out the coordinates so that you always remember if I have a point on my y-axis, the coordinates will be 0 is to negative 2. And then if I have a point on my x-axis, the coordinates must always be 1 is to 0 or x is to 0. And then the coordinates here will be 0 is to 3. Then we substitute your point of inflection. So y is equals to a bracket x plus 1. Not plus 1, it's supposed to be minus 1. So therefore, it will be x minus 1. X minus 1 cubed plus 0, because the value of q here is 0. And then you substitute a point. So our point is 0 is to 3. Where we see x, we have to substitute by 0. Where we see y, we substitute by 3. So 3 is equals to a bracket 0 minus 1 cubed. So 3 is equals to negative a. And then if you use your calculator to determine 0 minus 1 cubed, it will be 0 minus 1 cubed. And then the answer will be what? Negative 1. Hence, my answer here is negative a. And then you divide both sides by negative 1. Therefore, the value of a is negative 3. Therefore, y is equals to what? Y is equals to negative 3 bracket x minus what? Minus 3 cubed. So that is our equation of our cubic function. Yes. Now, let us carry on. Now, in the sketch alongside, it shows the graph of what? It shows the graph of f of x. So the graph of f of x is equals to ax cubed minus 9x squared plus bx minus 3. So in the sketch shown alongside, you are given the value of what? You are given the function, not the value. The function is what? Is ax cubed minus 9x squared plus bx minus 3. And what? 1 is to 2 is a stationary point of f. Now you are told to determine the values of a and b. So remember, when you check C, it is not familiar with what we were now discussing on finding the equation. But yet, you are required to determine the value of A and B. Now, these type of questions, they require you to use simultaneous. How so? Remember, you are given the function f of x as what? F of x is equals to ax cubed minus what? Minus 9x squared, and then plus bx minus 3. So now these type of equations, they require you to use the information that we have been doing, which is what? The stationary point. And also, you are given a stationary point. So how do we find the stationary point? For us to calculate the stationary point, when we started on sketching, for us to find the stationary point, we find the stationary point by doing what? By finding the derivative of the function and equating the derivative by 0. And then remember also, for us to find the coordinates of your stationary point, you were required to do what? After finding the x values, that same x value which you have obtained here, you had to substitute that x value onto the original to do what? To get the corresponding y value. So what we then do, we will be using that information to determine the values of A and B. So now we will have to find the derivative of ax cubed minus 9x squared plus bx minus 3, which is what? Which is f prime of x is equals to 3ax squared. Remember, you must multiply the coefficient of x cubed by what? You multiply the exponent by the coefficient of x cubed, which is a in this case. So 3 times a, it is 3a, and then 3 minus 1 will be 2, and then this will be minus 18x, and then plus b. Therefore, 0 is equals to 3ax squared minus 18x plus b. And then remember that x value, that's the x value of the stationary point. You must substitute it where you see x. Reason being, that x value of the stationary point, it is the same x value that you get when you do what? When you derive your cubic function and then factorize, so equate to 0. So that is why you are required to substitute that x value. So 0 is equals to 3a into 1 squared minus 18 into 1 plus b. So therefore 0 is equals to 3a minus 18 plus b. So now we have our first equation. Then remember the same x value of your stationary point. We took it and substituted that x value into what? Into your original for us to get the corresponding what? Y value. In this case, the corresponding y value is 2. So therefore, we will definitely substitute this point into the original equation of your cubic function. So where we see y, we will substitute by 2. So 2 is equals to what? A bracket 1 cubed minus 9 bracket 1 squared plus b into 1 minus 3. Because I know if I were to substitute that x value of 1 of my stationary point, I must get the corresponding y value as 2. Hence, now I substitute that as a point on my cubic function. So therefore, 2 is equals to a minus 9 plus b minus 3. And then if we were to transpose maybe minus 9, and yes, it will be 2. And then you add the like terms, right, before we transpose. So it will be a minus 9 minus 3. Minus 9 minus 3 will definitely give you minus 12. So it will be minus 12 plus b. So therefore, 2 plus 12 minus a is equals to b. I'm now making b the subject. So 2 plus 12 is 14. So it will be 14 minus a is equals to b. And then this will be your equation 2. So now these two equations, you must solve them simultaneously. So according to simultaneous, we know that we can substitute where we see b by 14 minus a. So therefore, right. So therefore, we will have to substitute what? 0 is equals to 3a minus 18, and then plus bracket 14. It's 14 plus 14 bracket plus 14 minus a. So therefore 0 is equals to 3a minus 18 plus 14. All right, minus a. So 3 minus a is 2a. And then minus 18 plus 14 is 4. And then we transpose positive 4, it will be negative 4 is equals to 2a. Then we divide by 2, divide by 2. Therefore, the value of a is negative 2. And then the same value of a, which you then obtained as negative 2, you must substitute that value of a into equation 2. And then that simply means you'll have to substitute a is equals to negative 2 into equation 2. Therefore, b is equals to what? B is equals to 14 minus negative 2, which is 16. So that is how we did what? That is how we determined the values of a and b. So please be on the look for what? For these types of what? For these types of cubic functions. Now determining the values of a and b. Right. So now moving on to the other one. Yes. So when we move on to the other one, remember, the sketch alongside shows the graph of what? Of y is equals to negative x cubed plus ax squared plus bx plus c. So this is what you are given. And then you have to determine the values of a, b, and c. So you have to determine the values of a, b, and c. So what you are given is y is equals to what? Is equals to negative x cubed plus ax squared plus bx plus c. So this is what you are given. And then also you are given a sketched cubic function. You have to determine the values of a, b, and c. So now when you look at this type of a cubic function, you have three unknowns, which are a, b, c. Unlike on the other example of which I did, you only had two unknowns, which were a and b. But in this case, we have three unknowns. But let us always remember that whenever we have a cubic function where now we have maybe a turning point, one of the x-intercepts are a turning point, the equation that you will be using will be what? y is equals to a bracket x minus x1, x minus x2, and then x minus x3, sorry, x2. So we repeat the what? The same value of x, where now the cubic function is turning. So now, because we don't know the other x-intercept, we can let this x-intercept be what? Negative k. Why negative k? Because when you look at your cubic function, I meant to say, this value of your x-intercept, it is what? It is on my left hand side. And all the values of x values that are on my left hand side are what? Are negative. So I know that whatever value of x, it must always be what? It must always be negative. So therefore, y is equals to a into x plus k, and then it will be what? X minus 2, x minus 2. So therefore, I will have y is equals to a into x plus k, and then x minus 2 squared. Yes, and then what we can also do, we can also substitute a point. We can also substitute a point, and then the point that you are given there is 3 to negative 6. So where we see x, we will substitute by what? By 3, and then where we see y, we will substitute by what? By negative what? Negative 6. So we can also answer this question like this. We substitute, it will be y. Negative 6 is equals to a bracket, and then x plus k. But remember, we said where we see you substitute by 3. My time is almost up. We substitute by 3 plus k, and then where we see but this was not even necessary. Let me save time, because already we could see that the value of a is negative 1. Why is the value of a negative 1? Because on your function you are given what? Negative x cubed. So that means when you are given a negative x cubed, the value of a, you substitute it as negative 1. Yes. So now to determine the value of k, yes, we will have to erase, yes, then this will be negative bracket. I apologize, because already we know the value of a. A, you are giving it here as what? This is what? This is negative 1. So there's no need. This will be negative, and then negative bracket 3 plus k, and then 3 minus 2 squared. So therefore, negative 6 is equals to negative bracket 3 plus k is multiplied by 1, because 3 minus 2 is 1, and then when you square 1, yes, you will definitely get 1. So therefore, minus 6 is equals to negative 3, and then minus 3k. So negative 6 plus 3 is equals to negative k. Therefore, negative 3 is equals to negative 3k. Therefore, k is equals to what? K is equals to what? Is equals to 1. So you will divide both sides by negative 3. So therefore, the value of k is 1. Therefore, y is equals to negative bracket x plus 1, because k is here, right? So it will be x plus 1, and then x minus 2, x minus 2. Therefore, y is equals to negative x plus 1, and then it will be x squared minus 4x plus 4. I apologize, now time is against me. Therefore, y is equals to negative bracket x cubed minus 4x squared, and then plus 4x plus x squared minus 4x, and then plus 4. Yes, so now, yes, you will then have to, when you look at your function, Therefore, it will be what? You will definitely have y is equals to negative x cubed plus what? Plus, let us add the like terms, and then this and that, it will be minus 3. So minus 3 times negative, it will be plus 3 x squared, and then the like terms will be, and then this one plus 4 minus 4, yes, they will cancel out, and therefore we will have yes, minus 4, and then yes, minus 4. So this will be the equation of our cubic function. So with that being said, I have a lot under cubic functions, but remember what we only did today was we were able to what? We were able to find the equation of the cubic function. We were also able to sketch. The only part I did not touch on is the part of what? Of interpretation. But I believe already this one of interpretation, this is the example of which I came with under interpretation. You were now asked to show that 8 minus 4b is that and that. But because already I've shown you how to answer this, I don't think that will be much of a challenge. But I really hope you are all well, and then wish you luck with your June examination. Yes, so there are so many slides that I did not do because of time. But I believe, with that being said, I wish you nothing but the best of luck with your upcoming June examination until we meet again. Thank you.